Now this problem is related to concept of angular impulse. Let us try this problem. So we have to find angular speeds of cylinder when slipping stops. Let us say we have these two cylinders that are in contact. Radii are R1 and R2. Angular velocity omega 1, omega 2. I1, I2 are moment of inertia. Let us call this cylinder as cylinder number 1 and this is cylinder number 2. This is point of contact between two cylinders. Let us make the free body diagram for cylinder 1 and cylinder 2. This point will have a linear velocity of r1 into omega 1. Similarly, this point will have a linear velocity of r2 into omega 2. Now direction of friction will depend upon value of r1 omega 1 and r2 omega 2. For example, let us say if I have r1 omega 1 is greater than r2 omega 2. So we are making this as assumption. This means this point has more velocity compared to this point. So I can say cylinder 1 is slipping over the cylinder 2. So this point is moving in this direction or slipping in this direction. Friction force will be in this direction. Friction force is always opposite to the relative slipping. This point is slipping in this direction, so friction force will be in this direction. Now if I apply Newton's third law, on this cylinder friction force will be in this direction. Now this friction force will try to decrease the omega because it will have a torque in this direction. So friction into R1, that is the torque. So friction will decrease omega 1 and it will increase omega 2. So you see here, torque of this friction is in this direction. That is, it will increase omega 2. So omega 1 increases, let us say finally it will become omega 1 dash. Omega 1 decreases basically, and after decrease it will become omega 1 dash. Omega 2 increases, and after increase it becomes omega 2 dash. Friction will stop when these two contact points will have same linear velocity, and at that point there will be no slipping. Will have same linear velocity. Linear velocity will be omega 1 dash into r1, and this is omega 2 dash into r2. We can show the same situation again, that is this situation. So we can draw the same diagram again. So we have this diagram. Initially we have omega 1 and omega 2. Finally it will become omega 1 dash, and this becomes omega 2 dash. So this is before, and this is when slipping stops. Now we can apply one equation for angular impulse. So angular impulse is equals to change in angular momentum. Now let us say apply for cylinder 1. Friction acts for time t. So t is the time for friction. So angular impulse is equals to torque into time, that is F into R1 into time. Since omega is in this direction, let us take friction is opposite, so torque of friction is opposite. So I am taking this direction as positive, torque is acting in this direction, so this is negative, is equals to final angular momentum minus initial angular momentum. Final angular momentum is I1 into omega 1 dash, and this is positive because in this direction we have taken as positive, minus initial angular momentum, that is I1 into omega 1. Let us call this is equation 2. Similarly we can write for cylinder 2. Torque is F into R2 into T. So angular impulse is F into R2 into T. Final angular momentum, that is I2 into omega 2 dash. This time angular impulse have positive sign because this is in the direction of omega. So omega is in this direction, angular impulse is also in this direction. So we have taken this direction as positive direction. Initial angular momentum is I2 into omega 2. So this is equation 3. From equation 2 and 3, we can equate the value of F into T. So we will have And we also know that is r1 omega 1 dash is equals to r2 omega 2 dash. So from here omega 1 dash is equals to we can solve for omega 2 dash. So let us take omega 2 dash common. R2 by R1 by R1. So this becomes R1 square. And this side we will have this goes right side minus cancels. This is I1. Now let us take LCM. So we will have so finally we will have omega 2 dash is equals to R1 R2 cancels. So we will have R1. This divided by I1 into R2 square plus I2 into R1 square. This is the value of omega 2 dash. Omega 1 dash will be, so we have R2 by R1 into omega 2 dash R1 cancels. This is R2. So this is the value of omega 1 dash and omega 2 dash respectively.